All right, so number 12. Well, number 10 and 11 were really involved and challenging. Number 12 was involved, but I think it's not as challenging. I think we just need to be careful with our process. So in this case right here, we're given a position function. Also up on the typo here. This is our position function of a particle moving along the x-axis, so it's just moving to the right and to the left. And I put it down as x squared. It's t squared minus 9 over 3t squared plus 8. And the first question is show the velocity, which is x prime of t, of the particle at time t is given by this. So literally find the derivative of this and make sure it's this. So I don't want to bore you with all the working out, but here we go. This is going to be the quotient rule, the derivative of the first, normal, second, blah, 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 blah. We then distribute through and clean it up a little bit. And when we clean it up a little bit, we get minus 54, so this becomes plus 54. And this becomes 70t over 3t squared plus 8 quantity squared. And that's part A. Done. Okay? Part B says, is the particle moving toward the origin or away from the origin at time t equals 2? Give us a reason for your answer. So when we're talking about a particle moving toward the origin or away from the origin, we need to know, is it moving to the right or wrong sheet before. Okay, so when we're looking if it's moving toward the origin or away from the origin, we need to know where its position is. In this case, it's negative 1/4 at 2. That means to the left of the origin. And we need to know its velocity, what direction it's moving in. And this was positive, therefore that's moving right. So it's to the left of the origin, moving right, therefore it's moving toward the origin. Okay, the simplification from here is pretty tricky. So we have our derivative of our first, normal second, minus derivative of the second, normal first. All right, and then we're trying to clean this up here. Well, to clean it up here, we need to look at these three pieces. There's 1, 2, 3 pieces here, all of which have a 3t squared plus 8 in common. So what I want to do, and by the way, this is squared, so let's do a fourth. Okay, so what I want to do is I want to clean it up as much as possible. That's my focus. Okay. I want to clean it up as much as possible, and what's going to happen is I'm going to cancel out 1 from the top, 1 from the top, and 1 from the bottom. That's equivalent to factoring a 3t squared plus 8 out of both terms on top and canceling at the bottom. It's the same idea, all right, of canceling that out. So don't overthink that process. Okay, so we already talked about canceling these out, so we now have this scenario right here. Recognizing the fact there's 70s on both sides, we're going to factor out a 70, and we're going to be left with 3t squared plus 8 minus 12t squared. So we can do that. Then this simplifies to negative 9t squared plus 8, and this is our acceleration at time t right there. All right. Now we evaluate this at 2, and we get negative 49 over 200. And that is part C. Okay, and again, the last problem is a limit problem. So what position of the particle does the particle approach as t approaches infinity? So they don't use the word limit. We have to know that's the word limit. But when we're talking about infinity, we're talking about end behavior, and we're talking about this function right here, t squared minus 9 over 3t squared plus 8, the same degree on the top and the bottom. Therefore, it becomes the ratio of the coefficients. Therefore, this is simply 1/3. Okay? So, as I said, number 12 was much more straightforward than the other two. I'm at 4:15 right now for time. So we have, the first one is find the derivative. We need to use quotient rule and simplify. Second one is moving away or toward the origin. That's going to be a tricky one. We need to determine our position, which was to the left, and our direction, which is to the right. Therefore, it's moving toward the origin. And the acceleration of the particle is the second derivative, but similar type stuff. And lastly, the limit as x approaches infinity, or t approaches infinity, is 1/3.